generator, solar panels for the power generating part. This wind one is not popular in our country. This is mostly the foreign farmers. They have their own small wind turbines. For harvesting and irrigation, you have electric water pumps, you have electric tractors, tilers, and so on and so forth. For post harvesting process as well, we have the harvesting machine, we have seed cleaner, we have vegetable cleaning, and then conveyors and elevators. Though you have not seen so many things in our country, but mostly they are popular in foreign countries, and few of them we obviously use in India. Now, if you see the main electrical machines, like our car, how it got evolved in day by day. So the first generation, that is the traditional ICE bus tractor, that where we take the diesel, we burn the diesel in the combustion engine like our normal petrol and diesel car. We burn it and then we use it to drive the wheels. Okay. Then the second generation comes when your IC engine, now it is partially replaced by the battery. Okay, just to reduce the emission from your car. So what is normally done? You have a lead acid battery previously. We used lead acid. So the IC engine is obviously that is used to drive the car, but the battery purpose of the battery is to supply the lights, ACs in the car. Or if it is a tractor, then you have a small light for your tractor. Those portions are done with the batteries. Now the third generation, from here actually the electrification of the tractor or the wheeling mechanism has been started, and that is around 1970. Okay. So after that, it has come series diesel electric tractor, where actually the IC engine is still there. And that is now after that, other than giving the diesel power or diesel engine directly to run your wheels, you convert it to electrical energy. And that electrical energy is actually running your tractor wheels with the help of a motor. Okay. Later, now you want to replace this IC engine because you can see the purpose of the IC engine we are trying to abolish day by day because we want to reduce the carbon emission. So day by day, we are just abolishing the use of IC engine for one purpose. Previously, it is full IC engine driven. Second, we replace the auxiliary loads, that means the lighting loads, with the help of battery. Third, we are converting your little bit of solar your IC engine, like diesel engine combustion energy to electrical, and then we are using a high performance electrical motors that your efficiency of the system will become high, that you need less diesel to run the entire tractor. Later, this IC engine has come as a backup supply. You will have mainly your batteries and you have a plug point connection as well that you can charge your batteries through your local system. This IC or fuel tank is only there when in mid of the field your battery dies off. Like it has got discharged in the mid of the field. At that time, you have to take that to the station to get it charged again. For that backup only, this fuel tank is there. Otherwise, it has not been used. And obviously, then again, you have a small solar panel as well when on the tractor. And then come this one, which is actually called the all electric tractor. You can see there is not even a fuel tank in that tractor. And actually, this kind of tractor is manufactured by John Deere company that is in US and they export everywhere. Okay. And multiple research innovations, they are doing it. India, we don't manufacture this. We use it, obviously. Yeah, but not in very large scale because it's a very costlier equipment. This last one is a very costlier tractor. Still in India, this is the most popular one. We have still have to travel a lot to catch up with the modern technology. This all electric tractor is almost few $1,000s. So because this battery itself make it very costly. Because now it is a lithium ion battery. So and tractor, normally car you need a smaller size battery, but tractor like you had to rush to a very rough road. So it has to be very powerful to drag that amount of, and tractor also the body is also very heavy. So that needs calls for a very high capacity battery, and that makes the overall system very costlier. Yeah. This is people they are use. Actually, the thing is that in US you don't have the access electricity. Obviously, you have at your home, but not like us. Like it is not that the sports are quite fixed there. Okay. Only we get actually they have two different kinds of supply. We have only 230 supply in our home. They have two different supplies. One is 110 volt, one is 220 volt. Okay. You can access only the 110 volt as a charging point or as a 3-port point. You can and only access the 110 volt. But these things are actually charged through the 220. Okay. So 220 open port is not available at your home. That for that you have to go to charging station. Okay. So they normally avoid to have this architecture where they have to daily charge. So they have to daily go to the charging station. So apart from that, what they do, they take the battery out. It is like a battery swapping method. They take the battery out, they brought to the charging station, dump it, take another full charged battery and keep it. Very fast charging. It is like swapping the battery. It is not even charging. You are not actually, yeah, there are multiple mechanisms. Even here also we have fast chargers that is on the highway side, which normally takes 30 minutes time to charge. But these are not for the tractors. These are for the electric vehicles like your cars. And these things I already told. This is your electrical system. So if you see the major equipment, that is a transformer, you have a solar panel, wind turbine, you have battery, water pump, fan. Water pump is actually a motor, nothing but it. So the most dominating thing in this entire system is this motor. Okay, motor and the panel, and I will tell how to do the maintenance of them. And again, if you see the tractors as well, you have the use of electric motors, you have the solar panel, you have converters, inverters. So now what is the impact of failure of this equipment? If something gets delayed, like if you are not really taking care of its life, then what will happen? First thing is that obviously your irrigation system will get disrupted. You cannot water your crop field. Second thing, your greenhouse that will lose all its environment, because if it is not properly watered or properly monitored, your ACs are not working, if you're not monitoring it, then your climate system will fail and your entire vegetation will be spoiled. Third one, if you don't take care of your solar panels properly, if it is dusty, or if you have mud on it, or it is broken, then the efficiency will go to 5% or 10%. That means what it is actually been installed to cater, or the purpose of it, that is entirely not been served. Then your tractors that can instantly fail, like when at the time of plucking or at the time of your harvesting time. If you don't know that the motor installed at your tractor is not properly well, because the failure will not be done or not occur instantly. It is like a cascading thing. First, a simple fault will happen. If you you all know, like other than this younger people, like 2012 event where the entire North India has been become dark. I don't know whether you have remembered or not. The entire North India power supply got cut from the power grid, and that lasts for almost 1 week. 2012, 2012. So entire South India only got like benefit, like not benefit, I should say, they disconnected them from the northern grid, and that's why they they survived. And that is called the blackout situation. Like when the entire western, like the Rajasthan, from Rajasthan to Assam, the entire North India got power cut. And that doesn't happen in one day. Sorry. It happened because of UP. If I say bluntly, this has happened because of UP, because everything has its, like every electrical equipment has its own capacity. If you take more, if you overstress it, then after some time it will fail. Same like your system. Like you have a capacity of working for 8 hours. If I stressed to do work for continuously 48 hours. After that, you will obviously fail. Okay. So let's say this 5 people, they are working one work. And as a boss, I am stressing him to do the 48 hours. So he will first break down. Then only 4 people left in the group. So the entire work now I am shifting to those 4 people. So they will also collapse one by one. So this is called the cascading failure. So this actually happened. What happened? UP doesn't have its own power plant. Okay. It takes entire power from the western and the eastern grid, like your Jharkhand and Bihar, and this side your Rajasthan and Gujarat and Maharashtra. Okay. And they are connected with only, I think, western grid is connected with 4 lines, and eastern grid is connected with 3 links, and this MP is connected with the UP 2 links. Like 2 big lines are there. So previously, what has been scheduled for the UP, they have not informed to the power grid. Like they knew that they have to consume almost 10 times what they have informed to the system. So what happened? Started consuming, and after that, one line got failed, but they didn't turn off their system. They didn't shed their load. So first line got out of order, then the second line, and that actually made the entire power system fall for the western grid fail. Like your entire Maharashtra, Rajasthan, and Gujarat power supply got dark. Still, they didn't stop. Then they took power from MP. Then MP got dark. Then they took power from eastern side. Then that got dark. Then they took power from northeastern grid, like on Assam and Arunachal. Then that got dark. They didn't shut their load off. So they took the entire power from the pool. That's why I told, like it's a pool. If you switch it on, the power will come to you. By hook or by crook. From where you are taking, that doesn't matter. So it's like a pond. If you take more water out of it, after some time it will get dried because the intake to that pond is fixed. So if the intake is fixed, after some time, one by one is getting cutting off from your pond. Okay. So that exactly happened, and that exacts happen with your system as well, like your tractors or electric vehicles as well. Let's say first the motor got a very small spark or small winding or small network got spoiled. You didn't take care of it, and you let the fault to be sustained for few more hours or few more days, and you are overburdening your tractor. So what will happen? After some time, again it will fail the another equipment, then another, and one fine day morning you just trying to drive it and it will stop working. And then your breakdown of the processing unit, it is same like your downtime. And it has been estimated that almost 30% loss is we see nowadays because of not doing this preventative maintenance properly, especially for the agricultural system. So what kind of maintenance work normally we prefer? That we do the first one. Jab sab kharab ho gaya, tab karo. That is the breakdown maintenance or reactive. When any equipment stops working, at that time we invest on that to rectify all the possibilities. Then come the second one, that is the preventative maintenance. It is a costlier. When everything is running also properly, at that time also periodically you are doing the maintenance. That is very lacking in our life, but still that is desirable. The third one, that is the predictive maintenance. That means you constantly monitor your system. Don't do the maintenance, but you constantly monitor your system. And if any point of time you see that the ideal operation has been deviated and your actual operation is not same as your ideal operation, at that time you can do the maintenance study, or you just fix that portion where the problem is there. But for that you need to have that continuous monitoring of your system. That is the primary requirement. So here comes the concept of condition monitoring. That is actually comes under the umbrella of predictive maintenance. Okay. So what is condition monitoring? Condition monitoring refers to the periodic assessment of any electrical equipment. That is called the condition monitoring. I will not go much deeper into what are the maintenance study we do, but generally that study has been done with the help of AI technique. That is easier to do. You put a sensor at your motor, You see how the current profile or the power profile look like. You need not to be an electrical engineer for that. You just take the ideal condition data, you compare that data with your actual condition and see whether any deformation or not. If there is any deformation, that means something is bad happening in your model. Then you open it and you correct it. So that is normally the data-driven process. And there are multiple ways of doing. So I hope you know CNN. Okay. So I will skip that one. These things are also, I think it is known to you. What are the learning techniques of CNN we use? Okay. So I explain it. So convolutional neural network, that is the next generation, or you can say it came around 2018 or 2019 into the market in a very rigorous manner, where the ANN one, like this is the ultimate ANN. So we give normally the ANN actually the whatever signal we got. That is why I showed in the last slide that you have your data, just dump it in at your ANN and see what is happening. CNN says with that data, you do some pre-study. You take those data and take some features. We call them features, which is the importance. That means which data are correlated with each other. Take only those data. And those data, you take the correlation coefficient, which is actually been done at the ANN randomly. But before doing that, you calculate with the help of convolution layer, convolution operation, you take those data out and then feed to the ANN. That can improvise the performance of the artificial neural network much better. That is why it is called convolutional neural network. You do first the convolution operation, followed by some feature reduction techniques, and then you feed that one ultimately to this fully connected layer. This fully connected layer is actually your artificial neural network. Okay, and that has been done, this feature extraction, if you put any image or any signal, that has been done by a filter or kernel. That is actually a randomly initiated. If you write a code in the Python, you just put a random file to generate a filter kernel. There is some that is called normally, if you find that file, that is called Xavier initialization. Okay, you have a file in Python. You just do the Xavier initialization. It will generate a random filter value for your CNN portal. And that you just do the convolution operation. You can see the mathematics. And that will create the number of features or number of important data you need for the classification purpose. Okay. Obviously, that much data you don't need because that will overburden your system. That has been done by the reduction, which is called the pooling algorithm. Like you select a simple portion. Let's say you select these 4 portions, 11, 12, minus 6, 5. I hope you know who have done image processing. The images are ranging from 0 to 255. The pixel value, each and every pixel value is from 0 to 255. Within that, whatever image you will see, black and white, gray, or color image, the pixel value at each and every box, looks like a matrix. Like when we say it is a 224 cross 224 matrix, like the pixel size is 224 cross 224. That means it's actually a matrix, mathematical matrix having 224 cross 224 element. Okay. And each and every element value, that value assigned to those element is actually the pixel value. It either, if it is close to 0, that means it's a very dark image, close to black color. If it is 255, that means it goes to the white color. So depending upon that, whatever is the range, depending upon that, you will get a pixel value at that location. So you do the filter, that is also a simple convolution matrix operation. Then you got some data. And from there, you always want the dominating features out of it. Because for a big image, let's say it is 1,000 cross 1,000 image. So with the convolution, you will get a huge amount of features out of it. You don't need all of them. Obviously you can process, but for that processing, you need a highly configured computer. Okay. So to avoid that one, you can put a pooling layer, which will select or which will say what is your dominating features. Okay. And then you convert and then you feed it to the ANN. Now, how you can learn your CNN or how you can make your CNN to learn any image or any signal. because you have a convolution layer, you have a pooling layer, you have a flattening layer, you have a fully connected or ANN layer that is at the last. But what operations you will do, depending upon that, you have three different learning techniques for the CNN topology. One is called plain learning. That means you give the input, you do first the first convolution operation. With that output, you do the second convolution operation. With that output, you do the third convolution operation, fourth, fifth, sixth, and so on. Okay. Like it is like you have only one input, modify it through a convolution operation. You got the modified or convolved output. Then you do the second operation. Then third, it is like a serial operation. But what is the problem with this operation? What is the problem? Anyone, any wild guess? The problem is that whatever input you give, after the operation, that input is completely lost. Because you have done multiple convolution operation, like multiple times you have multiplied your actual image with the help of some filters or some random filters, I could say. Okay. So actual image jo aapne diya tha, what is your input? At the output, you are doing something else. Like those features are completely lost. मतलब अगर image के कहीं पर if it was white color of 255 pixel value, after doing the modification, when it is reaching at the end, how it has become? Let's say it came to your value of 12. That means it has come to a close to dark. So when the comes for the classification, it will see that it's a dark color. But actually what it was a white color. So because of this discrepancy, this plain learning will always give you a very less accuracy. Okay. So here comes the next generation learning, which is called the residual learning. What residual learning does? Obviously, you cannot do everything with the initial. You do the convolution operation. After some time, you take again the input with you. Okay. That means with the convert or the output value, you take again the input. So you have modified or you have dominated your output with the again the input data. Okay. That has been modified. Further modification has been done with the dense learning, where not after some layers, but after every convolution operation, you take the input data again. But obviously, if you go for multiple operation or multiple dense learning, the training time will become very huge. And obviously, the computation complexity is very huge for the CNN. No, not feasible, I could not say. I have worked on this. But, and the problem is that for plain learning, if you need, let's say 100 layers, for residual learning, you need, let's say 50 layers. For dense learning, you need 20 layers. So number of layers is reducing. If that is the case, then more or less this needs a little bit of GPU configuration. Without GPU, you cannot do dense learning. Normal plain learning, even 100 layers is possible with your simple computer or laptop. But dense learning needs GPU system. Huh? Yeah. Little bit of high RAM, like 32 GB RAM is needed. You cannot perform any CNN algorithm with 8 GB or 16 GB RAM. That is not possible. We had the system, actually. We had the system, and otherwise, the best thing is that you use Google Colab. Google Colab, you have a good cloud information and cloud GPU. You can use it, and then you can run anything. No, your system like अपने laptop पे भी आप कर सकते. So with this, I will show 3 case studies. First in the conventional, and then I will go to a modified version of it. This is a motor we took from actually a farm, and we have seen this is the healthy. When it was healthy, it looked like this, and when it actually got fault, it looked like this. Okay. So you can see, like when we only opened, we have seen that the induction motor, now the motor from the inside, it when completely been spoiled. Okay. But we have seen it when it is actually not working. Okay. So how to modify this or how to make this sustainable? We have collected the data. Like we have took that motor and we have run it still and under that faulted condition or completely spoiled condition. we ran that motor and see how the current waveform look like. And similar configuration, similar make, a healthy motor we also bought, and we have seen the how the current look like for that healthy one. Okay. And if you see that this is your the healthy one, so every time it is coming out to be the same values, the uniform values. But when the fault is increasing, you can see there is some discrepancy. Like sometime it is less, sometime it is more, sometime it is less, sometime it is more. So this actually says that whenever your current is not properly distributed or properly not coming, that means something bad has happened to your system. But as a farmer, you cannot see it, right? So you need a smart algorithm. So that has been done with this CNN algorithm, where we have taken this dense learning, what I told, we have taken two dense block. This tree has been done with the convolution operation. This is also convolution operation. In between, we have a pooling operation. And we have seen whether you have a healthy motor or you have a moderately faulted motor or you have a severely faulted. That conditions we have checked, and almost the accuracy we got almost 94%. With few motors we did it. I have shown only the image of one motor. And we have seen that almost 94 times and out of 100 we got the result. But obviously sometime we are getting very erroneous result. Even the faulted section, they are showing it healthy. But actually it has been it is a small microprocessor chip we developed, tool thing, and we have checked with the motors installed in the irrigation purposes. This work is not associated with the agriculture, I could say, but this is done by me in our campus. Okay. We have this setup just to see, because in the greenhouse, you know that we have ACs and other devices like heaters, ACs, lights. How to know that which device is on at a certain time or not? So for that, you also need the data of it, but it is not obviously possible to open those devices at the greenhouse level. Hello? So this is not obviously possible to see, open that ACs at the greenhouse. So what I did, I actually prepared this tool. This is actually the box. Okay. And this is the device from where we can collect the data. Me and my friend, we roam around the entire IIT Roorkee campus to take the data from different devices. And we took the data for 18 different home appliances and 12 appliances which are running in combination. Because in greenhouse, you cannot expect that only one device will be on at a certain time. Okay, so total 18 single and 12 combinations we have checked. And these are the current profiles. Though we see everything is electrical, you can see now how the currents are actually look for different devices. The first one you can see that is for the desktop, like your computer. Second one is for your AC. Third one is for your CFL. Fourth one, like the top one, is for your incandescent light bulb. And this below one, this is for your washing machine. Though everything is electrical quantity, everything takes the power from your system, but you can see their power consumption pattern is completely different from each other. And when they get merged together with one another, you can see even their current pattern gets changed and multiplied like anything. Okay. So to design a system for this is a very challenging, because even you don't get any pattern. If you see the washing machine, sometime it get turned off and sometime it get turned on. Okay. So here also we applied the dense learning thing at the initial level when I was started learning the convolution neural network. And I have seen that, okay, the accuracy has reached to 93% with a simple CNN with a dense learning. Okay. Now this is another data. I have merged data from the standard one, like standard data set, with the data set we captured actually with the help of UAV. I think you had a session on UAV, how to fly UAV. So we actually flew an UAV at the agricultural session and also on the top of our electrical department to catch the images of what is the actual condition of the solar panels. And this is mainly done with the image section. You can see that actually the clean solar panel look like this. But if you have a bud drop, that means your then dusty, then physical damage, electrical damage. This snow data actually I take from a standard one just to make my system more robust. Okay, so these are the images of resolution 224 cross 224. And again, because the number of images are very less, because solar panel is not accessible at the village areas very easily, and our campus has only few places in IIT Roorkee. So we took only this first 4 and then the image augmentation. I hope that in this session they covered image augmentation. Okay, like you just take the image, you have multiple image augmentation tool in MATLAB and Python. Just you can do your brightness increase or decrease. What do you do in the filter, right? Zooming in, zooming out, brightness increasing, contrast increasing. What you do as a filter, the same thing you can do by coding as well. Okay, so you just can Google it or ask your uh, even your Python that what is the help desk, that what is the image augmentation. Yeah. So if you do it, then you will get image augmentation, and that will increase your number of actual images to duplicate it with different versions. And then we made it under 1,000 images, because for training the supervised learning, you need a huge number of images. That is the main restriction of using supervised learning. That can be ANN, that can be CNN, that can be any algorithm. But the data set size has to be very high to use CNN technology. So we have tested it on a already existing CNN module, so it has like quite an established one. That is your AlexNet, ResNet 50, VGG16, and DenseNet 121. Okay. So these are actually already established for other purposes, but we have used it and we have seen that this is your overall accuracy. Okay. Just it is a point per unit accuracy I have given. You just multiply with 100 and you will get the actual accuracy. The AlexNet has 5 layers, so that's why its accuracy is very less. It's only 67% accurate. Then VGG16, it is a 16 layer CNN, so we got almost 73%, and henceforth. Okay. Surprisingly, this time ResNet acted very bad, because we got why this happened, because normally in the major cases ResNet is very working properly, but that is the problem with the image when you work. Because image you are not collecting under the same environment, right? So what I told, ResNet works when your input features are good, but your RGB, everything is RGB. But whenever, let's say, some places we capture the data in a very sunlight, okay, so the panel, they are reflecting light like anything. So those features, when it comes for the ResNet and you take the decision, those are already very spoiled features or spoiled images. So that has been used for the classification. So in between, whatever modification has been done to rectify that problem, again that problem you have introduced after few layers. So that's why this ResNet actually that worked very bad. Now I will tell what are the drawbacks of this conventional CNN, which is still been uh, taught or First thing, what I told that the filters, and wait, I told that the Xavier initialization, that is actually a random initialization. You don't know whatever the images. You put the picture of horse, that will also image like generate a random filter. You put the solar panel image, that will also generate this random filter. Everything is random. It doesn't know whether it's a horse or a solar panel. Its purpose is to generate only random numbers. Okay. You don't have any knowledge about the physical domain. That means what is the image or what are the signals. That is why this learning and this lack of robustness you will see. Okay. So here comes this new concept, which is called physics informed neural network. This is a very new concept in the field of AI, which says that whatever supervised learning we use, that may be a neural network or maybe a CNN or maybe a LSTM, that is a black box model. You give input, you get output, you don't know what is happening inside it. And we are not even bothered of it. Okay. What is white box model? When we know everything, right? We know the physical or mathematical model of that system. We model it in an analytical way. We give input and we get the output. So we have full knowledge that why something is happening. Like you have a very good electrical model of your agriculture system or a tractor, and you know कि इतना diesel डालेंगे तो इतना mileage आएगा. Okay, that we know because of the specification of your combustion engine or your engine specification. Here comes, but that building that model for each and every component in a system is very difficult. And exactly modeling, that is also another challenge, mathematical modeling. If you can do it, then that is the best way possible in your career. That's why we cannot do it for the real life. This black box models has come. Now, what people are saying, even what I told about this Maha AI call of government, they want this physics informed. They want a system or an AI system to be developed, which will be specifically developing for a particular application. And that neural network will not learn abruptly or randomly. It will be learned in a specialized, channelized way. Okay, let's say you are trying to control your system or your AI model for watering and running an irrigation pump. Okay, but you have the data of fertilizer as well, right? So do you need really fertilizer data for irrigation? You need for soil. लेकिन कितना पानी चाहिए उसके ऊपर तो डिपेंड नहीं करता है डायरेक्टली एटलीस्ट. Okay, but when you feed that data as a black box, we don't know this connection. Like if you are not a very agricultural expert, okay, you will feed everything together and then training your black box model. But physics informed neural network will say you guide your neural network training in such a direction that it will not got deviate from the actual physics or actual operation of your system. Okay, so you just guide that learning. So how you can guide that learning? In a 4 different possible way. First, in the neural network, we know at the last we have a loss function, right? That has been taught, I guess, like the previous session. So you modified that loss function. Okay. Second, you get the actual physical model. I will come one by one to each and every one. Physics informed initialization. Then you design your ANN like the physics actually involved for that system. That may be any system. I'm talking about the generalized one. And then the last one is the hybrid model of your physics and the deep learning. So first one, which is the physics informed neural network, that has been for the loss function. Till now, whatever modeling we are using, we take only this part. This first part. That is a loss function, which is generally a mean average loss or random square loss, whatever. But we take only that, we give input, we see what is the loss value, again train our system depending up to reduce that loss value. That's it, right? And what it trains? It train only your weights and biases. Agree? यही तो होता है. Now, apart from that, you add this 2 extra terms. What is this 2 extra terms? This extra terms is actually your physics guided term. That means other than, let's say your ANN is to use to predict a solar power generation, or let's say it is predict how much crop growth you will get. Okay. Now crop growth, it is something way associated with the function of, if you can model it as a function of your how much watering you are doing. That is like if your watering is more at a certain point of time, your crop growth will increase, obviously. But if you overwater it, then it will start decreasing. Okay, so you have a pattern of it. It is not an abrupt situation, right? If you water plant to a certain extent or an optimal extent, your growth or your yield estimation will, net production yield will keep on increasing, right? But if you overwater your crop, then what will happen? Then it will start decreasing. So you have a proper physics in the relation of your watering of a crop and the crop growth. You use this physics for this extra loss term and you put that that if you do the overwatering, if your ANN model gives you overwatering solution, at that time it will create more loss value. That means it will learn by that penalty that overwatering is dangerous for my crop health. And that will be feedback again to channelize your or training your ANN model. Okay, did you get it? What is the pin idea? Previously, when it is a black box model, what it says, itna pani do, itna growth milega. Like a very simple linear equation. You give that this much of water and you will get this much of crop growth. Okay. So this is a very linear equation. Like with this, it got trained. But actually, what is happening in the real field? If you keep on increasing watering, will it give you a very good paddy field or very good growth of your agriculture production? No, right? At a certain peak value or certain watering amount, it will give you the highest one. After that, what is? After that, it is a flooding situation. And flooding will not give you a good solution, right? So that means that knowledge now you have to fit for your ANN. That knowledge has to pass on to your ANN because your ANN doesn't know it. So how will you put that? You can only put by looking that key by if you cross this threshold value, now you will be penalized. So that penalty you will add as a loss function for training your ANN. Okay. So first it will train, but with the every penalty it will get because of overwatering. So that is how this physics informed loss function works. And that is nothing to do with the initialization, nothing to do with your data. It is, you use the backpropagation. It is the same backpropagation you use. You just introduce this extra physics term, nothing else. Previously, your learning was unguided learning. Whatever data you have given, let's say for rice, you need more water. Okay. But for cabbage, you don't need more water. Okay. So that knowledge you have to pass to your, and similarly, the rice of one category needs more water, the other category needs less water. But if you just tell your ANN कि ये rice data hai, this is the water data, this is the soil data, cannot recognize whether that rice needs less data or not. With the rice, obviously, I will show. Yeah, I will show you. Okay. So this is the loss function. Then the second one comes physics informed initialization. That means you have, other than real-time data, you create some synthetic data. That is the ideal condition. Okay. So other than making your system to run randomly or learn randomly, you take some synthetic system that is a quite ideal system. You train your network like that. So something you will be guiding, like ideal system means it will obviously act ideally. So use that data to train for your real world system. Okay. So that has not been implemented for agriculture specifically, but that is one other approach to guide your physics informed neural network. Then the third thing, what I told you, is the physics informed design architecture. Let's say you will not design only for your ANN or the CNN model for one purpose. We have multiple purposes that एक ही system बनाएंगे, and that tool can serve for the entire agriculture system. Okay, means that can tell you how much you need, that will tell you how much watering you have to do, that will tell you how much investment you want to do. A single toolbox. If you go to a customer and say that this toolbox is only for watering, separate toolbox is only for fertilizer, then he will not buy. Like he has to install then 10 different toolbox for his one paddy field. So he wants a single solution for the entire agriculture system of him. Okay. Now for the, let's say for crop or for your electrical system or greenhouse gas or your, sorry, not gas, your greenhouse temperature maintenance, need the temperature data. That is fine. But do you need the fertilizer data for it? To keep your temperature constant or maintain that your, but that is also an input to your system. Fertilizer data also inputted to predict the soil condition. or watering condition, but that is not needed for your temperature one. But if you don't know that connection, what is the inherent nature of the ANN, it will create the connection between these two as well. Okay, though there is no connection physically in real life, they have no connection between the fertilizer and your AC temperature. But by nature of ANN or by nature of your CNN, it will create a connection between these two. So you have to tell the CNN that they have no connection. So you have to modify the architecture or the design of the neural network by saying that these two components are completely independent of each other. This input quantity has no connection with this output quantity. Then only your training will get better. So this is actually the physics. What is the physics? What is happening in real life? You just make him aware that your black box about the physical condition or the real life condition of your system. That is by any process. That can be by your loss function, that can be by your design architecture. And this is the last one, that is called a hybrid model, where you take the output from, but for implementing this model, you have to know the complete white model of your system. Very hard to do for agriculture at least. But you have to, if you somehow can derive that, you take the solution, like you completely dump that AI model or your white box model to train your black box model. If that is possible, then this is the best architecture. But this is very hard to do for most of the real life system. For my electrical system, this is very acceptable because we can model our electrical system in a very easy manner. Okay. But obviously, you can explore the research on this one. Physics can be anything. That is, I'm saying, like, let's say now you have to see what kind of work you want to do. That I told, like, you want to predict your soil condition, soil pH level, let's say, pH level. You want to predict the greenhouse temperature condition. One toolbox will predict everything, right? Like, can you clear your question a little bit? Yeah. Yeah, that is actually the white model. That is actually the white model. When you can actually model this, let's say your pH level and your fertilizer amount of fertilizer you put in the field. If you can model it mathematically as a function, like let's say you take a number, fertilizer given is your X and your pH is your Y. If you can represent Y equals to Fx, one one best way is to do is you study the data with the regression analysis other than giving it to the blind one like this ANN and all these things. You do either the curve fitting, that will give you at least a polynomial function from your input and the output. That is not, I will not say that is an exact one, but that will be a representation of your system. Okay, with let's say 90% accuracy. Okay, that how the soil nature and your fertilizer quantity will be modeled as a function. Data, that is I told that for agriculture system, relating this to is difficult. That's why I will show the examples which is different from this one. Like that is doesn't depend upon your loss function. That depends upon your connection. Like design, you can change the design. That is possible for agriculture. Because you know, at least as a human being, you know what is connected with whom. You forget about the data. Other than the data, you know the connection. What I told, you know the temperature is doesn't connect it with the fertilizer or the water, right? So this connection we know from our experience. So we use that experience to model the CNN. So again, with this CNN, so what are the major guiding factors? One is that filter, and second is this hidden layer. Okay, like this ANN connection. So one way you can just omit this hidden layer or ANN from your CNN. Why this ANN is needed? To train your system better. Okay. So if you can train your system better with this filter, that means this, other than having this filter randomly designed, if you can give your system that my filter has to look like this, like a particular structure, depending upon your input. If you can say your CNN strictly, then whatever features you will get, that is enough to do the classification. At that time, you don't need even ANN for the classification purpose. Okay, that has been done. I will show 3 examples. First is your fault one, like the fault example. That says that if your fault data look like this, then there is a concept of wavelet. I don't know whether you are aware of not, but wavelet is a kind of signal. It's very small signal. You can see there are total 16, 20 different kinds of wavelet signals are there. Okay, you can see everyone looks different from each other. Okay, these are very standard ones, standard signals. Wavelet, you can just search in Python, you will get this library. Okay, they named as Gaussian, Mayer, Mexican hat, Morlet, all this. So what you do, this is a very small one. You take this small one and superimpose on your data. Okay, and you check whether you are getting the final output better or not. Okay, sometime you will get better result, sometime obviously you will get bad result. But which one will give you the better result? That is actually the physics of your system. Okay, means this wavelet, you will act as a filter for your CNN structure. Other than having a random filter from your Python library, which will give you a random value of anything, you will give them this value that you put, that you take the Gaussian wavelet for your filter and see what is happening. So at least you know if the result is coming out to be 50% accurate, you know who is the main culprit of that 50% accuracy. Previously you don't know, right? When your filter is randomly generated, वो कौन generate कर रहा है? Python library कर रहा है. So huh? This signal, this is also a signal. This is not a image. I am showing it as an image, but this is also actually a signal. So signal, you just merge it. Okay. So I will come to the image also, like how to use image with this, not with this, but different kind of approach. Code I don't have now, but yeah, the thing is that these have some expression. The second one I will show with the expression. I forgot to put the mathematical expression for these wavelets. So this has some expression, okay. And this current also has some expression. That is a sign expression, simple sign. So now you match the convolution operation, what is shown as the convolution mathematics, you do with this two. Okay, they do with this two and see the final output with each and every one. And now see whether you are getting good accuracy or not compared to your random one. Okay. So we have implemented for a very simple shallow architecture with the CNN, with you can see with the residual learning. So that is giving, that is the WRCNN, that is giving me 96% accuracy. If don't take that your wavelet one as the filter, we are getting only 89% accuracy. Okay, so your accuracy has been increased by 7% because of this filter choice. So that choice matters. Other than keeping that choice or just seeding that choice on the Python library, क्योंकि Python library को थोड़ी पता है कि आप किसके लिए काम कर रहे हैं. You are just asking it to generate some filter. There is some code that you will just asking it to generate a filter code. Okay. It doesn't know that whether your filter code is for electrical signal or mechanical signal or computer science image or image processing or medical image, whatever it is. You put the image of brain tumor, this will also generate one filter. You put the image of solar panel, it will generate same filter. But those two cases are completely different from each other. Right. So you just guide that with what kind of filter it needs to generate. So these are the actual features look like. If you take your this Gaussian, Mexican hat and Mayer, the feature will look like this. Now here also one thing, where you have this dark complexion, that means those features are important for you. Now you can see for this Mayer, you have any dark complexion. It doesn't mean whatever physics you are giving that is correct. So if you train your CNN with this Mayer uh, filter, then sometime you will even guide to very bad solution. So it will at least say that we compared to this three, your Mexican hat is the best one. So that is the physics of your fault. That is the physics of your fault classification. So for any fault signal of this induction motor or any kind of fault one, if you use Mexican hat wavelet for deriving the features from at your convolutional neural network, that will give you more than 95% accuracy. So at least you know who is giving you 95% accuracy and who is not giving you 90% accuracy. So that clear cut idea you have to get for each and every application. Okay. I will skip this one. This is difficult thing. Now we'll come to the appliance one. That is the simple sinusoidal. Simple sinusoidal current. No fault, nothing. So that actually looks like, and if you zoom it, it looks like this. No deformation, nothing. Okay. So here you have seen how the architecture look like for the wavelets. थोड़ा सा ये था ना? These are not like every peak is not of equal length. Someone is very big peak, someone is very small peak. That is the case for the fault. But if you put the same value or same filter for your pure sinusoidal, will you get the result? Because this time your input signal doesn't look like that. So here we generated this sinusoidal signal, a sinusoidal filter. You look like this filter itself look like a sinusoid. It is better, let's say this is your filter, this is your actual input data. Convolution filter, how it takes the data feature out of it, it will put the filter, just merge it or paste it on top of your signal. Okay. And now you think for this variation, you put a random dot here and there. So it is not following your signal even. जहां पर मन किया वहां पर एक filter का value बिठा दिया. Okay. If that is the case, then sometime it may happen the signal flows through this side, but your filter is here. So what it will catch? What features it will derive? Nothing. So you need a filter which is just superimpose on your input signal just at it. And that has been done by this sinusoidal signal. Your sinusoidal signal, you can see, those are actually look like your current data. And then if you superimpose them, even without having a very deep architecture, only with two convolution layers, you can get 98% accuracy. But for the same layer, if you use that wavelet filter, how much accuracy you are getting? 94%. So this is the physics you have to know, that how your system look like or how your signal look like. So you know only the wavelet one. If you use wavelet for this purpose, you will not get result properly. Because now your input data is not even looking like a wavelet. It is look like a sinusoid. So you have to derive mathematically. That's why I told it is a physics informed. You know the physics of the input data or input system. You take that system and put that signal as a to derive the feature from your input data. Now I will come to the image. Okay. So here is the concept which is called image visibility filter. Okay. What is this visibility filter? Other than generating random filter, you take the filter from the image itself. क्योंकि इमेज में ही तो डिफॉर्मेशन था. If you see this bud drop image, these portions are actually the major bad portions. Okay. And you have to identify those portions only. Right? उसी portion के मतलब you know that this image will say that this is an image of a solar panel having bud because of which regions? Which regions in that entire image? कौन से region के लिए पूरे image का? Where the bud drop is actually there. So you have to match those portions with the other portion areas of your image. So take the filter out from that portion on. You take the filter, and that is called the image visibility filter. Whatever, yeah, that can be used for anything. Huh. So that can be done for anything. Okay. So what that is called image visibility. What is visible? Yeah. Choose that certain portion of that image. Yeah. At the training, you have to train the system. Testing image comes, now it will match with those filters, whether the same data is approaching to your testing image or not. If it is approaching, that means there is a bud drop. The same thing you can do for snow. It is not a template matching. It is like if you do one by one and then matching, that is quite tiresome job. Okay. So, but you see, you took this portions. Okay. The size is constant. Somewhere this bud drop will cover the entire size. Somewhere the bud drop is very small. Then what will happen? The rest of the portion is pure solar panel. Okay. So pure solar panel, in between you have three or four few portions where actually the dominating features is there. So this is learned by thousands of image visibility patches. This is called image visibility patch. What we take as a very small region of interest. Okay, that you take out from different images. That can be 5x5, 5x5. If jitna small aap lenge, if you take very small filters, that will give you good accuracy. But that will take large time to converge your system. But that will give you the highest accuracy. So for this study, we took only 5x5 because it's a 224 cross 224. So if you take 25 cross 25, then how many filters you will get? It's 40, around 40. But if you get 5 cross 5, then you can get 200. So 200 filters will give you 200 times good result. Like 200 times good features out of your actual image. And that one that I told, if that it doesn't mean that your bud drop has to be very big. Okay, it can be very small portion. So if you take a 25 cross 25, that what will happen? In the middle, let's say, you have a small deformation place. The other places are what? Those are normal, right? So those normal will now dominate your actual place. So you will lose that one. Like what is the purpose of your entire this image visibility? That is just to identify your bad portions. So take very small size filter that can take a 5 cross 5 element that will take the possibility of having redundant data or non-focus data will be very less. So how this image visibility will act? That will see what in that filter, whatever you have taken, what are the most dominating features. That means how this dominating features will be chosen. That will be chosen because I told that everything is between 0 to 255, right? So you sit on a place. Now, let's say you have a shorter person in front of you. Then you have a taller person after that. So you can directly see the taller person. Directly see it. So you see how much visibility you have. So if you see this image, if you take 176 as your concentration, 187 and then 201. So 187 is larger than him. 201 is even larger than. So these 2 points are visible for him, right? Then come to this diagonal one, 176, 148, visible. After that again 148. Is it visible? वो the same height पे ही है. You cannot recognize that whether that is present or not. Again, if you see, let's say you take this one and or okay, 218 and 237, or let's say replace this 201 with 180. Then will you see that 180 or behind 187? Like a shorter person behind a taller person. You cannot see him. So the filter will see that within that 5 cross 5 element or 25 element, which are dominating one. It will just pluck those and then try to get the features out of it. So this is the result. Now here you can see what are the places or where actually the good features or your dominating features lie. These are the normal AlexNet, VDD16, ResNet 50, and DenseNet 121. Now the least performing, if you can remember, the AlexNet only gave us 67% accuracy. We have just modified that AlexNet with the help of this image visibility filter. And you can see that this red portion is actually shows the region of interest. That means from where, because of which portion, you will get that classification done. Or it will recognize that image is bad, or it is a bird drop image, or it's a clear image, or it's a snow image. Okay. So if you see, if your red is more on that area, that means actual hampered area, that means your classification is good or your learning is good. So if you see that for normal AlexNet, where is that red? Let's say this is the solar panel with the snow. Where is the red portion? It is on the ground. So it is learning from the ground. That's why it got 67% accuracy. Because it is taking features or it is recognizing an image by looking at the ground, not even at the panel itself. Okay. But for now, if you see that red curve is on the panel, that means it is taking data or it is recognizing that as a solar panel covered with snow because it took the snow. It is not first region of interest is the solar panel in the entire image. After that, the snow portion. Okay. So it took actually the data from your snow and the panel portion. You see for same for this bird drop. Here is also panel is present. Okay. But from where it took the major data. It took where the bird drop concentration is very high. Similar for this one, and this one as well. Okay. So this is actually the physics informed that where other than giving the image classification on a random hand, you are telling that learn from the image itself or learn from the signal itself and then do the work. Then your, even if you see this AlexNet is 5 layer. So your learning time will also be very less compared to if you go to DenseNet, SqueezeNet, MobileNet, very deep network take hours after hours to train your network. And their AlexNet is taking only your 43 minutes. Now it is taking 50 minutes. So 1 hour time for training the entire data set. But if you take the DenseNet one for 90% accuracy, the almost the time taken is double for this data set, only 224 cross 224. So if you go higher dimension, obviously you will get more and more accuracy, but time bhi to matter karta hai. Your time should be restricted. So because of that, now we are obsoleting with this black box model and we are coming to the gray box model. So physics informed neural network is called the gray box model, where completely everything is not known, but at least you are guiding that learning to a specific direction. It is not even a black box as well. ब्लैक बॉक्स मतलब जिसके बारे में कुछ नहीं पता, व्हाइट बॉक्स मतलब जिसके बारे में सब पता है. बट ग्रे बॉक्स मीन्स वेर यू नो but not everything but few things. Okay, so these are the conclusions. I will not repeat the same thing. I told those things multiple times, and with this I will end my lecture today, and if you have any comment or question, you just can ask. So whatever I showed today, actually, no, still I have not made it public. I have to ask because these are all the project work. So I have to ask the competent authority that whether I can make it public or not. Information should be, if it is a supervised learning, obviously 100%. For gray box means, that is I'm saying why it is gray, because black box means the learning equation you don't know. Now you are putting that learning equation, or you are putting that filter. Previously the filter you don't know. Now you put that filter. अब उस filter से क्या feature आएगा that you don't know, right? Output feature, like whenever the convolution operation happens with the image, and whatever features you will get, that you don't know. But at least you know the filters. So you know something, you don't know also something. That is why it is called gray box. It's a gray area. White box functionality for deep learning is not there. No learning technique is white. Learning means from where you are learning from the data. So that can never be white. White learning means you are just solving simple numerical equations. आपके पास you have few linear equations, x1 plus x2 equals to 2, 2x 3x equals to 5. You solve it and get x1 x2. You have no other option. If you solve a simple white box equation, you will get unique solution at every place. आज आप solve कीजिए, अगर आपको 2 और 5 मिल रहे हैं, आप यूएस में बैठ के solve कीजिए, आपको 2 और 5 ही मिलेगा. You have no other solution possible. If that is the case, that is called the white box. That whatever input you are giving, if your solution gives an unique solution each and every time, even you run today, even you run 10 years after, that is called white box. Black box means it will never give you unique solution. आप run किए NN को, it is showing 93% accuracy. 2 मिनट बाद run कीजिए, it will show you 94% accuracy. उसके 2 मिनट बाद it will show 91% accuracy. So nothing is constant. So gray box model actually tries to reduce this variation. Now you have seen the variation from 90 to 95. Try to reduce this from 4.9 to 95.1. Kyunki when as an engineer we go to a customer to sell our product and we claim that our algorithm is 95% accurate. उसके टाइम पे उसके सामने चलाया and we have seen it is 92% accurate. क्या विश्वास रह जाएगा? That lab में तो आपने कुछ अलग बताया था, यहाँ के कुछ अलग बता रहे हैं. So he will not purchase. So trust बढ़ाना होगा. So black box model will not give you trust. Even I am telling you, even in the academic, now if you submit any article in black box model, it will never get accepted. Because the thing is that the result cannot be guaranteed. You cannot guarantee that this result you will get every time, even with the same data set. Because what is happening in between, you don't know. That this varies with your system configuration. This varies with the RAM you are using, whether it's the 8 GB RAM computer, 12 GB, even it varies with the memory allocation in your computer. If it is a lumped in one sector, it is distributed into different part of your memory. Everything depends upon your black box model. So we are just trying to obsolete that black box. The gray box model will not give you white box model accuracy, but at least because white box model accuracy is only possible when you know about a system 100%. Like we know our electrical system 100%. If you see any electrical modeling, that's a very perfect modeling. No other option, nothing is possible out of it. Let's say this agricultural system or any mechanical system or any other medical image. Let's say I worked with one of my friends on medical as well, and he works on this tumor and cancer recognition. Okay. The size of the cancer is different for each and every person. How will you recognize it? For some, it is very big. For some, it is very less. Okay. My lab is presently focusing on developing this physics informed neural network for power system. because now power system has a huge amount of data we are collecting. So we don't want the white box model, because white box model for a very big system solution is very difficult. It will not, you don't need a high computing facility, but you need a very high knowledgeable person who can model that big system in a very simple manner and solve those, let's say, like let's say a small system, very small system, let's say this home. If you want to solve this home, you will have at least 100 equations. At least 100 equations you need to solve to properly manage just this room. Now you think about this Jabalpur city. You have crores of equations you need to solve if you want to go for white box model. Black box is fine, but we don't want black box. Like power system engineers, power system operators don't trust black box model. So that's why my lab mostly they are working on white box. Sorry, the gray box model. Yeah, yeah. IEEE transaction is something which expect like completely novel idea, like but not in the scheme of solution thing. They want their, you don't come up with a new algorithm. You put like the CNN. CNN is a very old concept, right? It is a 10 years old concept. They don't want that you come to a new AI technique because that will cost you more. You modify in CNN to solve the new problem. That is what I told in the TV example. कुछ change TV में कीजिए ताकि electricity कम आए. It doesn't mean कि TV को ही change कर दीजिए. So IEEE looks for that. That you don't come with a new solution. You come with the old solution with a new version, but that will be able to solve the new problem. You have thousands of new problem in your paper on your hand. You try to solve those problems by modifying the existing solution algorithm. If you can match this two, then IEEE transaction is in the paper. Paper normally we do first thing is that we have to do some rigorous comparative analysis with the existing technologies, and we show that our is performing better, but it is not the case that for everyone you will get better result. So you have to do a trade-off. Let's say one algorithm is very fast, but the accuracy is 95. Mine is slow, like he is getting result in 10 minutes, I am getting in 15 minutes, but my accuracy is 98%. So we have to give a trade-off business between that. That because no, nothing is perfect. If something is perfect, then research ends there. So everyone has some flaw, everyone has some benefit. So you have to highlight properly, but both of them. Don't hide anything from the publisher. You show both of them that this is my benefit, this is my challenges. So I'm working on these challenges to reduce further. That is my future scope of my research. But these are the benefits as well. So now leave it to the reviewer, leave it to the editor to decide whether the benefit is more than challenge or lesser than that.